For this tutorial, I wanted to take a moment to discuss formatted output in Turing. Uh, if you've looked at previous tutorials or if you've done any kind of basic programming in Turing, you're already familiar with the idea of output. And so I can do things like put 3 plus 4 and I end up with an answer of 7. Or I can do simple division, put 5 divided by 3, and I end up with an answer of 1.666667. In this tutorial, we're going to be looking at the idea of formatting our output, which gives us a lot more control over how our output appears. So one of the things I'm going to do to assist us in talking about this is I'm actually going to put 0, 1, 2, 3, 4, 5. Actually, let's start with 1. 1, 2, 3, 4, 5, 6, 7, 8, 9, 0, which counts as 10. And then 1, 2, 3, 4, 5, 6, 7, 8, 9, 0. 1, 2, 3, 4, 5, 6, 7, 8, 9, 0. This type of output, especially when you're testing a program, can be very useful when it comes to getting a handle on spacing, because this basically lets me very quickly see where things are spaced. And so I can, here I've got out to 30 characters wide. And if I'm doing a program where the actual presentation of my information is important, sometimes spacing is one of the things that we're actually quite concerned with. So I'm going to go ahead and start with looking at spacing, because it can be very useful. So let's say I just want to put the number 33 or 32. There's 33. And if I run that, well, 33 is going to take up 2 spaces. Here's my spacing chart at the top, and then 33 takes up 2 spaces. But imagine that we were trying to output, let's say we were doing some sort of spreadsheet of numbers, and we wanted to have things equally spaced on the same line. Well, right now, that let's say I put 33, and then on the same line I want to put 44, and on the same line again I want to put 55. If I do this right now, as is, I'm just going to get 33, 44, 55, and they're all jammed together because of the dot operator, and I don't have any semblance of formatting here at all. If I wanted to make this look a little bit more like a spreadsheet, then one of the things I can do is I can use, and I'm gonna focus on this first, so I'm going to take these other ones away for now. I'll put them back. Turing has a formatting option, and you can look that up in the Turing help, and there's a complete sheet. I'll show that at the end of the tutorial just to show you where that is. But it uses the colon at the end of whatever it is that you want to output. And the simplest version of this is you put a colon, and then you basically you say what you're basically filling in here is how many spaces. That's the question that you're answering. So what I'm going to put after this colon is how many spaces do I want it to occupy. So let's say, well, in this case, imagine I wanted to, in my formatting, I did 3 groups of 10. So imagine I want to output my numbers and have each one in a column that's 10 digits wide. So in Turing, I can actually specify that by saying put 33 colon 10. And what that's going to do is it's going to put the number 33, and then it's going to use 10 spaces to display that number, no matter how big the number is. So let's just go ahead and run it and take a look. You can see here's the number 33, and if you look above, it has used up the first 10 spaces by inserting blanks in the first 8 spaces and then putting a 33 on the end there. I could, what if I put the number 3,333? I still want that to take up 10 spaces, so when I run that, you can see 3333 goes up to the 10th space, and it's only taking up those first 10 spaces. So let's see if we can go back to the example I had before and see about put 44, and I want that to take up 10 spaces, and put 55, and I want that to take up 10 spaces. I don't need that last dot. And when I run this, you'll see that the 3333 is in the first group of 10, 44 is in the second group of 10, and 55 is in the last group of 10. And I could keep doing this. So let me copy these 3, and I'll put 3 more And this time I'll choose, again, a random assortment of other numbers of varying sizes. And again, if I run this, you'll see that I'm starting to form these nice formatted columns, each of which takes up 10 spaces. So if I didn't have my little formatting guideline at the top, this is what it would look like. So if you were adding up columns of numbers or displaying things and you wanted this 3-column format, you could use formatting to accomplish that. Now there's another type of formatting. So we've just looked at the type of formatting that uses a single colon. There's another type of formatting you can use which actually makes use of a second colon. And this second colon is the number of decimal places. And so we can specify that with a second colon. Now that's not very useful for the number that I have right now. So the number I have right now is 3333. So why don't we put, we're going to put something there that'll produce a decimal. So how about 5 divided, actually I'm going to go with something more like, how about 50 divided by 3? So first of all, let's take away everything except for 50 divided by 3. And that gives us the answer of 16.666667, and that last 7 is rounded. So Turing will do that for you automatically. And by default, Turing will display 6 decimal places. It's actually capable of displaying up to 16 decimal places depending on the number, but by default it does 6. So once again, let's say I want that to take up 10 spaces, and if I run that, you can see here it makes it to the 0, and in this case it only had to put a single blank at the beginning, and then it takes up 10 spaces. So those 10 spaces include all of the numbers before the decimal point. It actually includes the decimal point, and it includes all of the fractional or all of the decimal numbers as well. That is no different than our previous example, but now I'm going to include the additional colon, and I'm going to specify, in this case, I'm going to specify 3. Now what is this saying? It's saying here's the number I want to produce. I want it to take up 10 digits worth of space, and I want it to have 3 digits in the fractional or the decimal component. So when I run that, you can see, again, here's 10 digits worth of space, and I've used more blank spaces this time because I only have 3 decimal places. It has actually been rounded. I could specify more than 6 decimal places. So I could, let's say I specified 8 decimal places. You might suspect that there's a problem here. So when I run that, let's see what I end up with. 16.6666667. I got 8 decimal places, but if you were paying close attention, you might have realized, hold on, I can't do that in 10 digits. And sure enough, I actually can't. This took 11 digits. So you have to be careful of that. The number of digits you specify here is overridden by the number of decimal places that you request here. So a simple solution to that would be to have given it more room, let's say 20 digits, and I go ahead and run that, and you can see now it's out to the second 0, so it's taking up 20 digits. All the leading stuff here is spaces. If you don't actually want to specify how long your number should be overall, Turing also allows you to put a 0 there. The 0 here says, just show me all of the numbers to the left of the decimal place. I just want to specify how many should occur to the right. So in this case, I'm just going to say 2, and if I run that, 16.67. I could change that to 5, and I would end up with 16.666667, 5 decimal places. But because I specified the 0 here, Turing doesn't actually try to add any blanks. It doesn't try to provide any formatting for me. So that's just an overview of output in Turing, and this can be very handy in allowing you to output things in a nicer manner. If you want to round numbers, that sort of thing, it allows you to present your data in a much more clean and formatted and deliberate way. So hopefully that's something that you can incorporate into your programming when it comes to producing nice output and good information for the user.